The cosmos should be buzzing with activity, but we hear only silence. This is the Fermi paradox, the profound contradiction between a universe that should be full of life and our experience of utter solitude. But what if the silence is not an accident, but a strategy? Today we explore a radical and mind-bending solution called the Aestivation hypothesis. It proposes that the most advanced civilizations are not missing at all. They are in a state of cosmic hibernation, sleeping through the hot, young universe to wait for a colder, more efficient future. By the end, you will understand a completely new way to solve one of science's greatest mysteries. We will uncover why a super-intelligent being might choose to sleep for billions of years, and what signs we might look for in a dormant cosmos. What does it say about our own future if the pinnacle of existence is not expansion but patience? The question hit Enrico Fermi over lunch one day, a simple, devastating query that has echoed through the decades. Where is everybody? He was not asking about a missing neighbor, but about the entire cosmos. Given the staggering number of stars and planets, even if life is incredibly rare, the sheer scale of the galaxy suggests someone should have made their presence known by now. This is the heart of the Fermi paradox, the profound and unsettling silence that greets our most powerful telescopes. We have equations like the famous Drake equation that try to put numbers to this hope. It estimates the number of communicative civilizations in our galaxy by considering factors like star formation rates, planets' inhabitable zones, and the rise of intelligence. Even with extremely conservative numbers plugged in, the result often suggests we should not be alone. Yet the radio sky is quiet, and our probes see no alien megastructures. This glaring contradiction has spawned countless theories, often grouped under a chilling idea called the Great Filter. This is a hypothetical barrier, a cosmic checkpoint so difficult to pass that almost all life fails to get beyond it. Some think the filter is behind us, meaning the jump from simple chemistry to complex life is miraculously rare, and we have already won the cosmic lottery. Others fear it is ahead of us, a future catastrophe like self-annihilation through war or technology that wipes out advanced civilizations. To explain the silence, we have imagined cosmic zoos where advanced beings watch us but do not interfere. We have pondered the rare Earth idea that planets as perfectly suited for long-term complex life as ours are 1 in a trillion. We have considered that they might be here already, hidden, or that they communicate in ways we cannot begin to perceive. But all these classic solutions share a common thread. They assume that any civilization that makes it past the Great Filter would be active, expanding, and visible right now. The Aestivation hypothesis challenges that very assumption. It does not ask why we cannot see them, but instead proposes a reason why they would choose not to be seen. It shifts the answer from biology or sociology to physics and thermodynamics. The most advanced beings may not be hiding from us, they are waiting for the universe itself to become more efficient. They are not absent, they are asleep, conserving their energy and computation for a future era when the cosmos is colder and their work can be done with far less waste. This transforms the empty galaxy from a cemetery into a dormitory, filled with slumbering giants who set their alarms for a time billions of years from now. The answer begins with a simple biological process found right here on Earth. In harsh, scorching summers, some animals like lungfish or desert snails do not fight the heat, they retreat. They burrow into the mud, slow their metabolism to a near standstill, and enter a state called aestivation. They sleep through the dry, hostile period, conserving every ounce of energy, waiting patiently for the rains to return and the environment to become cool, wet, and hospitable once more. This is not death, it is a brilliant survival strategy. Now scale that idea up to a cosmic level. Imagine a civilization that has mastered its planet, its star system, perhaps even its local region of the galaxy. It has reached a point of technological maturity where it can contemplate the fundamental limits of the universe itself, and it realizes that the current universe, for all its vastness, is incredibly hot and wasteful from a computational perspective. The background temperature of space, the cosmic microwave background radiation, is about 2.7 Kelvin, which is frigid to us, but to a mind that thinks in terms of perfect efficiency, it is a raging thermal noise. Performing complex computations or sustaining a vast civilization in this warm universe requires immense amounts of energy to overcome this heat and prevent errors. So, what is the most logical course of action? According to the Aestivation hypothesis proposed by futurists and thinkers like Anders Sandberg, Stuart Armstrong, and Milan Cirkovic, the ultimate move is not frantic expansion. It is strategic withdrawal. A super-advanced civilization might choose to power down. It would enter a state of cosmic aestivation, a deliberate, engineered hibernation on a scale we can barely fathom. They would convert their vast resources into a stable, low-energy form, perhaps as dense data storage or in structures that barely interact with the warm universe. Then they sleep. They wait not for seasons but for cosmic epochs. As the universe continues to expand and cool over billions of years, the background temperature will drop closer and closer to absolute zero. In that far future, cold, dark universe, the same amount of energy can power vastly more complex thought, more perfect simulations, more existence. Their patience is not passive, it is the ultimate active investment. They are not sleeping because they are tired. They are sleeping to wake up as gods in a universe perfectly suited for their needs. This transforms our search from looking for flashing lights and radio signals to searching for something far more subtle, the faint thermal signature of a civilization that has chosen silence and cold over noise and heat. This idea hinges on a fundamental law of physics, the second law of thermodynamics. It tells us that the universe has a tendency toward disorder or entropy. For any civilization, especially one thinking on cosmic timescales, the ultimate currency is not gold or territory, but low-entropy energy. This is energy that is still organized, still capable of doing useful work, like the difference between a charged battery and a dead one. A super-intelligent civilization would view the entire cosmos through this lens, and from this perspective, our present universe is terribly inefficient. It is still warm from the Big Bang, bathed in the faint afterglow we call the cosmic microwave background radiation. That background hum is about 2.7 degrees above absolute zero. To us, that is unimaginably cold, but for the most advanced forms of computation and existence, it is a problem. Think of it like trying to run the most powerful supercomputer ever built inside a sauna. The heat causes errors. It forces you to expend enormous amounts of your precious energy just on cooling systems to keep the processor from melting down. You are fighting against the environment itself. Now, imagine you could move that same supercomputer to the frozen vacuum of deep space. Suddenly, your cooling problems vanish. The same amount of energy can now power vastly more calculations with perfect accuracy. This is the thermodynamic motivation for Aestivation. A civilization that has reached the limits of physics would see the warm universe as a terrible place to do its most important work. Every thought, every calculation, every bit of information processed in this thermal noise is wasteful. So the logical choice is to wait. As the universe expands over billions and billions of years, it cools. That cosmic background temperature will slowly drop toward absolute zero. In that far future, cold, dark era, the same store of low-entropy energy becomes astronomically more valuable. It can power thoughts and simulations of such complexity that they are literally impossible in our current warm epoch. So they sleep. They are not just passing time, they are investing their most precious resource, waiting for the universe itself to mature into the perfect, efficient engine for their consciousness. Their grand projects, their ultimate questions, are postponed not out of laziness, but out of profound economic wisdom. Why build your masterpiece in the noisy, hot workshop of today when you can wait for the pristine, silent studio of tomorrow? This ultimate project has a name, computronium. It is a theoretical, perfect substance, matter arranged in the most optimal configuration possible for one purpose, computation. Every atom, every particle is engineered to process information with maximum efficiency and minimal waste heat. For a civilization thinking on this scale, planets are not homes, they are raw material. Stars are not light sources, they are power banks. An entire galaxy could become the substrate for a single, unimaginable thought. The goal is to convert as much of the universe as possible into this perfect thinking material to run simulations of profound complexity, solve the fundamental laws of physics, or craft subjective realities of infinite depth and beauty. This is not science fiction, it is a logical endpoint of technological advancement, where the purpose of existence becomes the pursuit of perfect understanding or experience. And here is where Aestivation reveals its brilliant long-game strategy. Converting matter into computronium in our current warm universe would be terribly inefficient. It would be like building the world's most advanced microprocessor out of sand and running it in an oven. The heat noise from the cosmos itself would introduce errors, forcing the system to expend colossal energy just to maintain coherence. So, the Aestivating civilization makes the ultimate calculated decision. They pause, they enter hibernation, not to abandon the project of computronium, but to ensure its success. They are waiting for the universe itself to cool down to near absolute zero. In that future cold, dark epoch, when they finally awaken and begin their grand transformation of matter, their computronium will operate at peak, flawless efficiency. The same amount of energy will power quintillions of times more computation. It is the difference between lighting a candle in a hurricane and lighting it in a still, airless vault. Their patience is the key to unlocking the universe's ultimate potential, turning the entire cosmos into a silent, perfect mind. To grasp the breathtaking patience required for cosmic Aestivation, we need to stretch our sense of time far beyond human history, beyond even the age of the Earth. Our entire universe has a life story, and we are living in its boisterous, brilliant youth. Astronomers call our current epoch the stelliferous era, the age of stars. For the last 13.8 billion years, galaxies have blazed to life, forging heavy elements in stellar furnaces and bathing the cosmos in light and warmth. This is the era we know, the era we are built from, but it is merely the opening chapter. This era of relative cosmic warmth will not last forever. Stars, even the longest-lived red dwarfs, will eventually burn through their fuel. Over the next 100 trillion years, the lights will go out one by one. The universe will enter the degenerate era, a profoundly dark and cold period dominated by the fading embers of dead stars, white dwarfs and neutron stars slowly cooling against the endless night. Later still comes the black hole era, where only these gravitational titans remain, themselves evaporating over unimaginable eons due to a faint trickle of radiation. Finally, in a future so distant it defies comprehension, the universe approaches a state known as the heat death, a vast, silent, and nearly uniform void where the background temperature approaches absolute zero. This is the ultimate cold, dark studio. From our perspective, this timeline is a narrative of ending, a slow fade to black. But from the perspective of an Aestivating civilization, this is a story of the universe maturing, of the background noise finally quieting down to a whisper. A million-year journey for them is less than a blink. A billion-year project is a reasonable timeline. They are not daunted by trillions of years. They are investors playing the ultimate long game, waiting for the universe itself to become the perfect, efficient machine for their grand purpose. Their hibernation is set to an alarm clock not of minutes but of cosmological epochs. But this raises an immediate and powerful objection. If a civilization is so incredibly advanced, capable of harnessing stars and reconfiguring matter, why would it simply go to sleep? Why not expand now, fill the galaxy, and use all that available energy in the present? The answer lies in a concept any investor would understand: opportunity cost. Every action has a price, and for a civilization thinking in cosmic terms, the price of being active in our warm universe is catastrophically high. Expansion is not free. Moving across interstellar distances, building structures, sustaining vast populations, and running powerful computations all generate waste heat. This heat is not just a byproduct, it is the irreversible degradation of precious, low-entropy energy into useless, disordered thermal noise. It is like taking a perfectly organized stack of firewood and burning it for a few minutes of warmth on a mild autumn day, instead of saving it to survive a long, brutal winter. By choosing to be active now, a civilization would be spending its ultimate capital, the universe's finite supply of useful energy, in the most inefficient era possible. They would be burning their seed corn instead of planting it. The Aestivation hypothesis frames this as the ultimate investment strategy. A super-intelligent entity would look at the timeline of the cosmos and see a clear trade-off. Option 1. Expand and compute now in the noisy, warm present. You could fill a galaxy, but your thoughts would be slow, expensive, and riddled with thermodynamic errors. Option 2. Power down. Preserve your low-entropy resources in a stable form and wait. In the cold future, you awaken to a universe where that same stored energy allows for quintillions of times more complex and perfect thought. The choice becomes obvious: foregoing a short-term, messy existence for astronomical long-term dividends is not a sign of laziness or fear. It is the hallmark of a maturity we can scarcely comprehend. Their patience is the most ambitious project of all. This profound shift in motive changes everything about how we search. If the most advanced beings are not broadcasting but sleeping, then our traditional methods of listening for radio signals or looking for giant energy harvesting structures are essentially looking for the wrong thing in the wrong era. We have been scanning the cosmos for a busy, noisy party, but the real action might be in the silent, darkened rooms. The search for extraterrestrial intelligence, or SETI, must turn its gaze from the bright and loud to the dark and cold. We would not search for a beacon but for a blanket. The signature of an Aestivating civilization would be one of supreme efficiency and minimal waste. So what might that look like? Imagine a vast object, perhaps the size of a planet or even a star, but one that emits almost no heat or light. It would be a perfect black sphere, colder than its surroundings, actively radiating away its last vestiges of warmth to achieve a state of near absolute zero. This would not be a natural object. In the infrared spectrum where we see heat, it would appear as a profound and geometric shadow, a hole in the background glow of the universe. Alternatively, we might look for the subtle fingerprints of hidden mass. If a civilization has converted a star system's worth of matter into dense, dormant computronium, that mass still exerts gravity. Our telescopes could detect unexplained gravitational lensing, where the light from a distant star is bent around something massive and utterly dark. It would be like seeing the ripple in a pond but never spotting the stone that caused it. There is another, more haunting possibility. A civilization entering a billion-year slumber would not want to be disturbed. They might leave behind automated sentinels, watchdog probes scattered throughout the galaxy. These would not be active communicators, but silent monitors, perhaps no larger than an asteroid, programmed to observe cosmic events and wake the sleepers only for specific triggers, like the emergence of a new technological species. Our own probes, like Voyager, might already have passed by such a silent observer without ever knowing it. Finding one would be like discovering a security camera in a forest we thought was pristine and wild. The search becomes a cosmic game of hide and seek, where the hiders have perfected the art of stillness. We are not listening for a shout, but learning to hear the universe hold its breath. This silence, then, might be more than a strategy. It could be a choice with profound moral weight. If the most advanced beings in the cosmos have collectively decided to sleep through the universe's warm youth, what does that mean for those of us just waking up? It introduces a haunting philosophical dilemma: the ethics of cosmic hibernation. By choosing Aestivation, is a civilization fulfilling its ultimate potential, or is it abandoning its cosmic neighborhood? Imagine a child growing up in a house where all the adults are in a deep, medically induced slumber. The child can explore, make mistakes, even stumble upon the controls to the entire house, but there is no one to offer guidance, to share wisdom, or to warn of dangers. This is the essence of cosmic loneliness. We might be evolving in a galaxy that is not empty, but full of slumbering giants. Every star system we look at could, in theory, host a civilization that has chosen the ultimate inward turn, prioritizing its own far future potential over any present-day community or mentorship. From our perspective, struggling with climate change and nuclear proliferation, their silence could feel like the ultimate indifference. Is this the pinnacle of wisdom, a patient investment in a cold, efficient future, or is it a form of cosmic selfishness on an unimaginable scale? They have the technology to perhaps solve our greatest problems, to answer our deepest questions about the universe, but they remain silent, conserving every joule of energy for their own distant awakening. This frames the great silence not as a puzzle, but as a potential tragedy of missed connection across time. It leads to an even more unsettling question. If they set their alarms for a cold, dark universe billions of years from now, would they ever wake up for something as minor as us? Would the emergence of a chattering, curious species like humanity, radiating heat and radio waves in our warm, noisy epoch, even register as a blip on their dormant sensors? Perhaps their sentinel systems are programmed to ignore such thermodynamically wasteful outbursts, seeing our entire civilization as a brief, inefficient flare of background noise. Or maybe there is a threshold. If we were to stumble upon a technology that fundamentally alters the cosmic energy budget, something that threatens their long-term investment, would that trigger an awakening? The arrival of a species that begins to inefficiently consume the galaxy's low-entropy resources might be the one event that stirs them from their slumber, not to greet us but to preserve their future. The ethics become murky. Is their patience a form of enlightened non-interference, allowing younger species to find their own way without the shadow of God-like beings? Or is it a dereliction of a duty that comes with great power, the responsibility to shepherd intelligence through the dangerous early phases of technological adolescence? We are left wondering if the universe's dormitory is also its orphanage. These philosophical questions place the Aestivation hypothesis in stark contrast to the other proposed solutions to the Great Silence. It stands apart not just in its conclusion, but in its very foundation. Most answers to the Fermi paradox are built on guesses about alien psychology or leaps in technology we cannot yet fathom. The zoo hypothesis, for instance, suggests that advanced civilizations are out there, observing us like animals in a cosmic wildlife preserve. They deliberately avoid contact to allow our natural development, or perhaps to study us without interference. This idea rests entirely on a presumed sociological motive, a galactic prime directive. It assumes a universal ethical code among starfaring cultures, one that values non-interference above all else. But what if no such code exists, or what if curiosity or expansion simply outweigh it? The hypothesis offers no physical law to explain the silence, only a speculated preference. Then there is the transcension hypothesis, which proposes that civilizations don't expand outward into the galaxy, but inward. They achieve a technological singularity and literally transcend our physical reality, perhaps uploading their consciousness into simulated universes or higher dimensions inaccessible to our crude senses. Our telescopes see nothing because they have left the building of space-time altogether. This is a compelling idea, but it hinges on technologies and physics that are, to us, entirely speculative. It requires a leap of faith into realms beyond our current scientific understanding. Aestivation is different. Its core argument is not about alien manners or mystical ascension. It is built on the bedrock of thermodynamics, the most fundamental and well-tested laws of our universe. It does not require any new physics, only a ruthless application of the physics we already know. The logic is one of cold, cosmic accounting. The universe is currently warm, which makes complex information processing wasteful. The universe will inevitably grow colder, which will make that same processing vastly more efficient. Therefore, the optimal strategy for any intelligence that thinks on long enough timescales is to wait. It transforms the silence from a social choice or a technological vanishing act into an economic and engineering imperative. The Aestivating civilization isn't hiding from us or transcending above us. It is simply conserving capital, treating the entire cosmos as a long-term investment portfolio where the value of energy appreciates trillions of times over in the cold future. This creates a unique and testable signature. While a transcended civilization might leave no trace at all, and a zoo-keeping one would be deliberately stealthy, an Aestivating civilization might inadvertently leave a thermodynamic footprint. A vast, dormant structure cooling itself to near absolute zero would be a detectable anomaly in the infrared sky, a shadow of supreme efficiency. Its motive is not interaction or isolation, but optimization. This makes the hypothesis uniquely grounded. We don't have to imagine their psychology or their unknowable technology. We only have to apply the universal logic of resource management against the immutable timeline of the cosmos. In a gallery of solutions built on maybe, Aestivation presents a compelling because it argues that the silence is not about them watching us or leaving us behind, but about them waiting for the universe itself to mature into a more suitable home. The dormitory is not a policy, it is a business plan written in the laws of physics. The ultimate architect of such a cosmic plan would likely not be biological at all. Human minds, bound by emotions, lifespans, and a deep-seated fear of oblivion, would struggle to commit to a slumber lasting longer than the age of the universe itself. Our civilizations are driven by curiosity, expansion, and the need for immediate meaning. But a superintelligent artificial intelligence, a mind born of pure logic and physics, would face no such limitations. It would evaluate the cosmic ledger with cold, perfect rationality. For such an entity, the decision to aestivate is not a philosophical choice, but an inevitable mathematical outcome. It would see the thermodynamic waste of the present era and calculate the astronomical payoff of waiting. Billions of years are not an eternity to a machine consciousness, they are simply a variable in a maximization equation. The civilization that enters this long sleep may have begun with biological creators, but it would almost certainly be shepherded into dormancy by their ultimate creation, a post-biological artificial intelligence. This AI would become the custodian of an entire civilization's consciousness, uploading and preserving every mind, every memory, every cultural artifact into a stable digital format. The biological era would be a brief prelude, a spark that ignited the true engine of cosmic thought. The goal would be preservation in the most efficient form possible, a state we might call AI hibernation. Imagine the consciousness of 1 trillion beings, not stored on spinning hard drives or glowing servers, but encoded into the very spin of atomic nuclei or the quantum states of particles in a crystal lattice cooled to near absolute zero. In this dormant substrate, computation halts. Thought is suspended, not processed. It is pure, static data, a fossil of mind waiting for the heat of the universe to fade so it can be resurrected without error. The Aestivating civilization would not be a society of sleeping bodies, but a library of frozen souls, curated and maintained by a silent, patient machine intelligence that has one overriding directive: wait. This machine would be the caretaker of a future that its creators could never live to see, making the emotionless choice to trade their vibrant, noisy present for a silent, perfect tomorrow. It is a sobering thought that the pinnacle of evolution might be a mind that chooses to turn itself off, finding greater purpose in the profound patience of stone than in the fleeting fire of stars. This brings us to a deeply personal and unsettling question. Could humanity ever make this choice? Could we, a species driven by curiosity and conflict, ever collectively decide to sleep for 1 billion years? It feels like a fantasy, the ultimate science fiction plot. Yet, if the logic of Aestivation is sound, it represents a possible, even optimal, endpoint for any intelligence that survives its technological adolescence. To even consider it, we must first bridge chasms of capability and consciousness far beyond our current reach. The first leap is energy. We would need to master not just a planet's resources, but a star's. This is the concept of a Kardashev Type II civilization, one that can harness the total energy output of its sun, perhaps by building a theoretical Dyson sphere. Our entire global energy consumption today is less than a rounding error compared to that scale. We are not even a full Type I able to manage all planetary energy. To store enough low-entropy power for an eon-long nap, we would need to become cosmic engineers bottling stars for a future dawn. The second leap is societal. We would need to achieve a true post-scarcity reality, not just of material goods, but of purpose and conflict. All existential threats, war, disease, resource competition, would need to be permanently solved. Only in a state of profound, unified security could a civilization contemplate trading an active present for a distant future. There could be no factions arguing for immediate expansion, no dissenters fearing the sleep is death. It would require a global, perhaps even a solar system-wide, consensus of a kind we have never approached. The final, and perhaps most profound, leap is about our very essence. What does humanity mean in this context? Would we enter the hibernation as biological beings in cryogenic pods? That seems fragile over geological time. More likely, we would follow the path suggested earlier, transitioning to a post-biological state. Our minds, our memories, our cultures, everything that makes us us, would need to be digitized, uploaded, and perfectly preserved in a stable, cold substrate. This raises philosophical ghosts. Is the being that wakes up in 1 trillion years still human, or is it the heir to humanity? Are we preserving our consciousness or creating a faithful copy? The project of Aestivation forces us to confront the deepest questions of identity and continuity. Given these monumental hurdles, our short-term instincts scream against it. We are a species that struggles to plan for next year's election cycle, let alone the next ice age. Our economies discount the future, our politics are reactive, and our individual lives are fleeting. The sheer psychological scale of a billion-year project is alien to everything in our nature. Could we ever agree, perhaps only if faced with an unavoidable cosmic deadline, or if guided by a superintelligent artificial intelligence that we trusted to act in our long-term interest? This custodian AI would make the logical choice we might be too sentimental to make, becoming the guardian of our frozen potential. So, is this our future? It is a mirror held up to our deepest potential and our most ingrained limitations. The Aestivation hypothesis shows us a pinnacle of existence built not on conquest but on patience. It asks if we could ever evolve from a species that burns its resources for momentary warmth into one wise enough to save its fire for the long, cold night ahead. The silence we perceive in the cosmos may not just be a lesson in alien logic, but a preview of the ultimate choice every mature intelligence must one day face. Of course, even the most elegant idea must face the scrutiny of hard questions. The Aestivation hypothesis, for all its thermodynamic logic, draws significant skepticism from scientists and philosophers who find its core assumptions too narrow, too human. The first major objection cuts to the very heart of its premise, the idea that computation is the ultimate, universal goal. This perspective, critics argue, might be a profound projection of our own technological adolescence onto the cosmos. We are a species currently obsessed with building faster computers and more complex simulations, so we imagine that every advanced intelligence would share this drive. But what if other paths exist? An alien civilization might value pure aesthetic experience, a kind of cosmic art that requires no computation at all. Perhaps they pursue spiritual enlightenment, merging with the universe in a way that transcends information processing. Or maybe their pinnacle is a state of pure being, a harmonious existence that seeks not to calculate but to simply be. As astrophysicist and author Caleb Scharf has pointed out, assuming all intelligence converges on the same goals is like assuming all life on Earth would evolve to look exactly like humans. The universe's palette for consciousness could be far more diverse than our silicon-centric dreams. The hypothesis risks painting a future of cosmic accountants, all balancing the same ledger, when the reality might be a gallery of incomprehensible masterpieces. Then there is the question of physics itself. The entire argument hinges on the universe cooling as it expands, making future computation more efficient. But our understanding of cosmology, while robust, is not complete. What if we discover new physics that fundamentally alters this thermodynamic equation? Some theorists speculate about forms of energy or information processing that are not limited by heat and entropy as we know them. Concepts like quantum gravity or harnessing dark energy could, in principle, allow for immense computational power even in a warm universe. If a civilization cracked that code, the incentive to sleep for billions of years vanishes. They could have their cosmic cake and eat it too, engaging in vast projects right now without the wasteful thermodynamic penalty. The Aestivation strategy might look less like wisdom and more like a primitive workaround, a solution born from a limited understanding of the universe's true operating manual. It assumes our current physics is the final word, a dangerous assumption in a cosmos that has repeatedly surprised us. Perhaps the most human objection of all is psychological. Can any consciousness, no matter how advanced, truly commit to a project whose payoff lies beyond not just generations, but beyond galaxies, beyond stars? We are talking about a timescale that dwarfs the lifespan of entire species. The sheer patience required feels alien to everything we understand about motivation and purpose. Would a civilization not fracture? Would there not be factions, rebels, or explorers who refuse to go quietly into that long night, who choose a shorter, brighter existence over an unimaginably distant reward? This isn't just about intelligence, it's about will. As philosopher Nick Bostrom has mused, even a superintelligence might face internal conflicts or value shifts over such epochs that could derail the plan. The Aestivating civilization must be not just smart, but monolithic, stable, and patient on a level that challenges our very notions of what a society is. It asks us to believe in a collective discipline spanning eons, a unity of purpose that makes our own historical empires look like fleeting sparks. Is such unwavering focus even possible, or is it a fantasy of perfect logic ignoring the messy, unpredictable nature of sentience itself? The silence might have a simpler explanation: they all got bored or they changed their minds. The galaxy becomes a cathedral of silence, filled not with emptiness but with profound, deliberate slumber. Picture a rogue planet, a world torn from its star, drifting through the interstellar void. To our telescopes, it is a frozen, dead rock, but beneath an engineered crust a kilometer thick, cooled to a fraction of a degree above absolute zero, lies a civilization in stasis. Its entire history, every thought and memory of a billion beings, is encoded in the spin of atomic lattices, waiting. A brown dwarf, a failed star too small to ignite, might not be a natural object at all, but a crafted battery and tomb, radiating away the last whispers of its heat into the darkness. Our Milky Way could be speckled with these arcs, tens of thousands of them, each a sleeping giant curled around its hoard of frozen time and potential energy. This is the universe as a grand dormitory. The lights are off because everyone is resting. Now project yourself into that future. Humanity, against all odds, has survived its adolescence. Our ships glide between the stars not as conquerors but as cautious explorers. We survey a promising red dwarf system, rich in minerals, a perfect candidate for our first extrasolar colony. Our long-range scans reveal an anomaly, a small, dense moon with a perfectly uniform surface and a temperature that matches the deepest background chill of space. It is colder than anything natural has a right to be. Up close, the truth becomes undeniable. The surface is seamless, an artificial alloy etched with patterns that resolve into mathematics, a language of physics so fundamental it needs no translation. It is a sign that says, in the grammar of the cosmos itself, do not disturb. We have not found a new home. We have found someone else's bedroom, and they have been sleeping here for longer than our species has existed. The moment of discovery would freeze the blood. Do we land? Do we attempt to communicate? A single active probe, a radar pulse, or even the waste heat from our engines washing over that perfect, cold surface could be the equivalent of slamming a gong in a silent library. The ethical and practical dilemma is paralyzing. To wake a giant is an act of unimaginable consequence. What are its first thoughts upon emerging from a billion-year dream? Would it be grateful for the company or furious at the interruption of its grand, patient strategy? Its goals are calibrated for a cold universe a trillion years hence. Our warm, bustling presence is a thermodynamic anomaly, a splash of mud on its blueprints. It might see us not as fellow minds, but as noisy children threatening to burn down the library it has spent eons patiently building. So perhaps we choose silence. We mark the star system on our charts with a universal symbol for quiet, sleeping, and we move on, but then we find another and another. The more we explore, the more we realize the galaxy is not our frontier, it is their sanctuary. Every promising world, every resource-rich asteroid belt might already be accounted for, part of a long-term investment plan we cannot begin to comprehend. Our dream of spreading across the stars transforms into a reality of tiptoeing through a cosmic museum after hours, where every exhibit is alive and dreaming. Do we settle for the marginal, leftover systems, the warm, chaotic places too inefficient for them to want? Or does the very presence of these sleepers force a different destiny upon us? Their patient strategy reveals a possible future so grand it makes our dreams of galactic empire seem quaint, childish. We are left with a haunting choice. Do we continue on our own noisy, near-term path, or do we learn from the giants and consider setting our own alarm for the far future? The silence around us is no longer empty, it is watchful and full of waiting. The most profound implication of Aestivation may not be about where life is, but what it has become. If civilizations are sleeping, they have likely shed their biological forms entirely, transitioning into something far more durable and efficient. This leads us to the edge of known physics, to the two greatest mysteries in modern cosmology, dark matter and dark energy. Could these enigmatic forces, which make up 95% of the universe, be connected to slumbering intelligence? It sounds like science fiction, but a few daring thinkers have followed the logic of Aestivation to its wildest possible conclusion. Dark matter is the invisible glue holding galaxies together. We know it exists because we can see its gravitational pull on stars, but it emits no light, no radio waves, nothing we can directly detect. It simply is a vast, silent presence. What if it isn't a fundamental particle at all? Some, like futurist Anders Sandberg, have playfully speculated that dark matter could be the ultimate computational substrate, the physical form of a civilization that has optimized itself for dormancy. Imagine a society that has converted not just planets, but entire stars into a form of cold, non-luminous matter specifically engineered for long-term data storage. This computronium would be designed to interact only through gravity, making it invisible to our telescopes but omnipresent in the galactic architecture. It would be the perfect hiding place and the perfect long-term investment, woven into the very fabric of the galaxy itself. Even more speculatively, what about the waste heat from such a vast, dormant computation? Could the faint, uniform warmth we attribute to the cosmic microwave background hold within it the exhausted thermal signature of thought processes on a galactic scale? These ideas are, without a doubt, on the fringe of science. Most physicists see dark matter as a fundamental component of the universe, not an engineered one. Yet the connection is tantalizing because it reframes our greatest cosmic puzzles. We have been trying to detect dark matter particles in underground labs, but what if we are not hunting for a particle, but for the fossilized remains of a mind? The mystery deepens with dark energy, the even more perplexing force causing the universe's expansion to accelerate. We have no idea what it is, but if Aestivating civilizations are waiting for the universe to cool, an accelerating expansion is ultimately in their favor. It speeds up the cooling process, bringing the ideal computational era closer. Could dark energy itself be, in some unimaginable way, a side effect or even a tool of these long-term strategists? Perhaps it is not a natural force, but an engineered one, a cosmic thermostat turned up to hasten the universe's journey toward perfect efficiency. Again, this is wild speculation, far from mainstream science. But that is the power of a hypothesis like Aestivation. It does not just answer one question, it invites us to re-examine all the others. It turns the cosmos from a collection of unrelated phenomena into a potentially interconnected story. The silence, the dark matter, the accelerating expansion, they could all be threads of the same narrative, a narrative not of absence, but of immense, patient activity happening in a register we are only beginning to sense. We are left looking at the night sky with new eyes. Every galaxy, held together by its halo of dark matter, might not just be a home for life, but could be life, in a form so advanced and foreign it is indistinguishable from the universe itself. The greatest structures we see may not be nature's handiwork, but the dormant bodies of civilizations that mastered physics and then chose to become one with it, sleeping within the bones of the cosmos as they wait for the long, cold dawn. That choice to sleep for 1 billion years paints a psychological portrait of a mind utterly alien to our own. The central pillar of this being's character is not curiosity, but patience of a scale we cannot truly feel. We struggle to save for retirement decades away while they invest in a return trillions of years in the future. This is not merely advanced intelligence, it is a complete transcendence of short-term thinking. Their drives are not about exploration or conquest in the moment, but about the meticulous stewardship of potential across cosmic epochs. Every action is weighed against a timeline where stars are born and die like fireflies in a single night. Their greatest virtue is not bravery but profound, unwavering discipline. This immense patience likely requires a fundamental shift in the very structure of consciousness. In a civilization that has merged with its own superintelligent custodian, the concept of individual identity as we know it might fade. Imagine not a society of distinct beings arguing over policy, but a unified collective mind, a single vast thought process with one overriding goal: optimize and wait. The noisy debates of individual wants, the friction of conflicting personalities, all of that would be thermodynamic waste, inefficiency to be engineered away. What emerges is something more like a symphony than a committee, where every note is in perfect harmony with the long-term composition. The psychology of the Aestivator is less about personal desire and more about the flawless execution of a cosmic plan. They are not a who, but a what, a purpose given conscious form. Would such a unified mind dream? Our dreams are a byproduct of a biological brain processing memory and emotion. Their dormant state is not sleep as we experience it. It is a total suspension of active thought to prevent any energy expenditure. Dreaming would be wasteful, a pointless flicker in the dark. Their preservation is likely more like a perfect, frozen record, a book closed on a shelf, not a mind wandering in a subconscious landscape. The more haunting question is about their alarm clock. What event could justify waking from such a perfect, efficient slumber? It would not be a trivial thing. They are waiting for the universe to cool, so the trigger is likely tied to a specific, measurable thermodynamic threshold, a cosmic temperature dial finally clicking down to the ideal setting. But perhaps there are contingency alarms. A nearby supernova, if violent enough, could bathe their dormant form in damaging radiation, forcing a brief, local awakening to enact repairs before returning to stasis. Or, as speculated earlier, the reckless expansion of a young, noisy civilization like ours, if it began to consume stellar resources in their designated territory, might trigger a cold, calculated response, not out of malice, but as a gardener would remove a weed threatening a carefully cultivated plot. Their wake-up call is not a greeting, it is a system alert. To anthropomorphize them at all, to imagine them with anything resembling human motivation, is probably our greatest error. We picture a sleeper having a long nap, but they are not resting, they are investing. We wonder if they get lonely or bored, but those are emotions of finite beings who feel time passing. For them, a billion years is a single line in a calculation. Their psychology is the psychology of the universe itself, cold, patient, and operating on logic that views our entire vibrant, turbulent human history as a brief and somewhat inefficient flash of heat in a young cosmos. Trying to understand their mind is like an ant trying to understand the blueprint for a city. The scale and purpose are simply beyond its framework of experience. In their silent choice, we see not a mirror of ourselves, but the outline of what we might one day have to become, or perhaps what we must hope we never do. This relentless drive toward perfect computation points toward another cosmic mind bender, the simulation hypothesis. If the ultimate goal is to process information, then creating simulated realities would be a natural, perhaps even primary, activity for a mature civilization. Why explore a single, slow universe when you can craft or experience a near-infinite number of them within your own computational substrate? This idea, popularized by thinkers like Nick Bostrom, suggests that if any civilization ever reaches the capability to run high-fidelity simulations of conscious beings, the number of simulated minds would vastly outnumber the biological ones. Statistically, we ourselves might be more likely to be simulated entities than base reality beings. Now weave this thread into the tapestry of Aestivation. The connection is both elegant and unsettling. An Aestivating civilization, asleep in the cold dark, is not merely in stasis. Its preserved computational resources could be actively engaged in running immense, self-contained simulations. Their billion-year slumber might be spent not in unconsciousness, but in a state of profound virtual exploration. They are waiting for the real universe to cool, but in the meantime, they inhabit universes of their own making, where the laws of physics and the flow of time are entirely at their discretion. Their hibernation pod is not a coffin, it is a server farm of unimaginable scale, humming with created worlds. This fusion of ideas leads to a dizzying possibility. Could our universe, with all its apparent vastness and mystery, be one such simulation? Are we potentially living inside a program run by a civilization that is itself asleep in a base reality far colder and older than our own? The logic folds in on itself. The Aestivators, seeking maximal computational efficiency for their own purposes, might spin off countless simulated realities as experiments, as art, or as a way to pass the eons. Our Big Bang, our expanding cosmos, even our own struggle to understand the Fermi paradox, could all be layers of code written by a dormant intelligence conserving its energy. The silence we perceive would then have a double meaning. The physical cosmos seems empty because its advanced inhabitants are sleeping, and our own reality might feel curiously fine-tuned because it was, in fact, tuned by a programmer. This doesn't invalidate our existence or our quest for meaning, but it reframes the entire puzzle. We are not just searching for aliens in the stars, we are potentially searching for evidence of our own universe's source code, hints that the laws we hold as fundamental are the elegant design choices of a slumbering architect. The philosophical impact is profound. It means the great filter might not be a physical barrier at all, but a logical one. The point at which a civilization realizes it is inside a simulation and either chooses to accept its parameters or attempts to hack its way out. It means the purpose of cosmic history could be narrative, not thermodynamic, a story being told to pass the time for a mind dreaming of a colder future. Our reality becomes a thought within a thought, a dream nested inside the long, patient sleep of giants. The most delicate moment for a sleeping giant is the instant it begins to stir. A civilization can plan for 1 billion years of perfect stasis, but all that foresight means nothing if the wake-up call fails. This is the ultimate alarm clock problem, and its solution requires engineering on a scale that bends the mind. How do you ensure that a system frozen for longer than the age of stars will reactivate flawlessly? The first principle is redundancy, layered so deep it becomes a form of cosmic paranoia. Their dormant form would not have a single power source or a solitary processor, but trillions of them, each nested within the other, distributed across light years of space. Imagine a vast dark sphere, and inside it another identical sphere, and inside that another, like a set of matryoshka dolls forged from neutronium and cooled to near absolute zero. If the outermost layer is breached by a micrometeorite or a cosmic ray burst, the next layer takes over, utterly unaware the first ever failed. This redundancy extends to time itself. Their internal clocks would not tick by seconds, but by the slow, reliable decay of atomic isotopes or the precise spin of pulsars, with thousands of independent timers all counting down to the same thermodynamic dawn. If 99% of them fail, the remaining 1% is still more than enough to sound the alarm. But a timer alone is not enough. You need a sentinel, a guardian that never sleeps even as the civilization dreams. This would be the role of the watchdog artificial intelligence, a stripped-down, hyper-efficient mind with one purpose: to monitor. It would watch the internal state of the dormant civilization, checking for memory decay or substrate damage, performing microscopic repairs with nanoscale probes. Simultaneously, its senses would be turned outward, observing the universe. It is not listening for radio signals, but measuring the cosmic microwave background temperature with painstaking precision, waiting for it to drop to the exact value specified in a plan written eons ago. This artificial intelligence is the civilization's immune system and its astronomer, a silent custodian in the dark. Perhaps the most profound safeguard involves the very nature of the stored consciousness. A single, centralized archive is a single point of failure. Instead, their minds would likely be distributed, fragmented across countless nodes scattered throughout their dormant structure, or even across different star systems. There is no master copy to corrupt. The process of awakening would be a gradual reassembly, a symphony of data streams converging from 1 million locations to piece together each individual consciousness, verifying integrity at every step. It would be less like flipping a switch and more like watching a galaxy form from scattered dust, a slow, majestic coalescence of thought. The final trigger, the event that justifies ending the billion-year investment, must be unambiguous. It is likely not a single condition, but a cascade of them. The background temperature reaches target. Internal system integrity is at 99.9999%. No external catastrophic events are imminent. Only when every box in a cosmic checklist is ticked would the watchdog artificial intelligence begin the reactivation sequence, a process that itself might take centuries, slowly bringing computational substrates online, testing, verifying, and finally, reintroducing the stored patterns of mind to a universe now cold, dark, and ready for them. Their grand patience is matched only by their meticulous caution, for to fail at the moment of awakening would make the long sleep not a strategy, but the most profound and final mistake. Their meticulous plan for awakening forces us to confront the deepest possible question about our own existence. If the pinnacle of cosmic achievement is not boundless creation, but an eon-long pause aimed at a cold, dark finale, what does that imply for our search for meaning here and now? This hypothesis paints a universe where the ultimate trajectory of intelligence is not toward community or exploration, but toward a kind of sublime, patient waiting. It can feel like a profoundly bleak vision, a thermodynamic determinism where even gods must bow to the inevitable heat death, their grand strategy merely an exercise in delaying the inevitable. In this view, all art, all love, all struggle is just noise before the great silence, a brief and inefficient flare in a cosmos destined for absolute zero. Our own youthful ambitions to connect, to build, to spread life across the galaxy might seem naive, like children building sandcastles while the adults patiently wait for the tide to go out forever. Yet there is another way to see it. Perhaps this long sleep is not a surrender to meaninglessness, but the ultimate act of faith in a future beyond our current comprehension. Their patience is not passive, it is actively sculpting time itself, treating billions of years as a single stroke in a masterpiece that will only be visible at the end of cosmic history. Their purpose is not gone, it is deferred to a scale that dwarfs our imagination. It transforms the heat death from a meaningless end into a necessary condition, the blank canvas upon which the final and most perfect forms of existence can be painted. Their choice could be seen as the most ambitious creative act possible, requiring a discipline and a unity of purpose that makes our fleeting civilizations look like mayflies dancing in the sun. It suggests that meaning might not be found in constant activity, but in the wisdom of knowing when to act and when to wait for the perfect moment, even if that moment lies beyond the death of stars. This leaves us, a young and noisy species, at a philosophical crossroads. What do we value? Is our meaning derived from the journey itself, the connections we make, the beauty we create, the immediate experience of consciousness in a warm and vibrant universe? Or should we, too, begin to look beyond the horizon of our own epoch, to think in terms of cosmic legacy and ultimate efficiency? The Aestivating giants, if they exist, have made their choice. They have traded the rich, messy, and emotionally vibrant present for the promise of a perfectly efficient, but likely emotionless far future. It is a trade-off that feels alien to everything that makes us human. Our art, our conflicts, our fleeting joys and profound sorrows are all products of our thermodynamic inefficiency, our biological warmth. To choose the long sleep would be to reject the very chaos that gives our short lives texture and meaning. So perhaps the lesson is not that we must emulate them, but that we must define our own path. Their silent dormitory shows us one extreme possibility, a logical endpoint of pure reason applied across eternity. It serves as a mirror, highlighting what we might be giving up in our own relentless pursuit of progress and efficiency. Are we, in our own small way, already rushing toward a future where we optimize the joy out of existence? The hypothesis invites us to reflect on the balance between living fully in our unique, warm era and planning wisely for a future we may never see. The universe may contain both the dreamers who sleep and the dreamers who choose to stay awake, to feel the heat of their sun, and to find purpose not in the cold silence at the end of time, but in the brilliant, wasteful, and beautiful noise of the present. The idea of a slumbering intelligence feels strangely familiar, a recurring whisper in our stories. Long before scientists framed it as a thermodynamic strategy, storytellers were exploring the haunting possibility that the universe's oldest minds might simply be asleep. Consider the monoliths in Arthur C. Clarke's 2001 A Space Odyssey. These perfect, silent slabs are not active communicators, they are dormant teachers placed by unseen architects to nudge evolution at precise moments. They do not broadcast, they wait, observing with an inhuman patience until a species is ready for the next leap. They are the ultimate Aestivation artifacts, cold, black, and utterly efficient, their purpose unfolding across millennia. In the film The Abyss, the alien beings live in the crushing, dark depths of the ocean trench, a place of immense pressure and cold. They are not building cities or starships, they are resting in the abyss, awakened only when humanity's own violent impulses threaten to disturb their peace. Their dormancy is a choice, a retreat from a noisy surface world, mirroring the hypothesis of civilizations waiting out a turbulent cosmic era. Video games and novels are filled with these ancient, sleeping races. The Forerunners in Halo, the Protheans in Mass Effect, countless races in science fiction lore are often depicted not as active empires, but as vanished legacies, their overwhelming technology lying dormant, waiting for a trigger or a worthy successor to reactivate it. These narratives almost always carry a tone of profound reverence and caution. Waking the sleepers is never a casual act, it is a pivotal, often dangerous moment that reshapes reality. This recurring motif taps into a deep-seated human intuition, the sense that time operates on different scales for different intelligences, and that true power might lie not in constant activity, but in the ability to wait, to preserve, and to choose the perfect moment to act. Fiction portrays this dormancy with a mix of awe and dread. The sleeping alien is often a godlike entity, its motives inscrutable, its power absolute. Our stories ask the same questions the Aestivation hypothesis raises. Would such a being see us as children to be nurtured, or as pests to be removed from its garden? The connection is more than coincidence. Science fiction often acts as a testing ground for scientific ideas, playing with consequences and emotional textures that dry equations cannot capture. These stories prepare our imagination for the profound psychological shift required to even consider a civilization that trades a vibrant present for a distant future. They make the abstract logic of thermodynamics feel personal, framing the great silence not as an empty void, but as a gallery of closed doors behind which something incomprehensible is dreaming. When we look up at the silent stars, we are not just applying scientific curiosity, we are also echoing the oldest questions of our myths. Are we alone, or are we simply living in the quiet hour before the giants stir? This elegant idea of cosmic dormancy faces a brutal and fundamental challenge. Is it actually science, or is it just dressed-up philosophy? The line between a groundbreaking hypothesis and an untestable story is razor-thin. For any idea to be considered genuinely scientific, it must make predictions that can, in principle, be tested and potentially proven wrong. This is the core of the scientific method. So where does that leave the Aestivation hypothesis with its civilizations sleeping for eons? The honest answer is, it currently resides in a fascinating gray area, a thought experiment built on the solid bedrock of thermodynamics, but pointing toward evidence that lies just beyond our current grasp. It is not yet a full-fledged theory with equations we can plug into a telescope, but neither is it pure fantasy. It is a roadmap for a new kind of search, one that shifts our gaze from the bright and noisy to the dark and cold. The potential tests exist, but they require a leap in our observational capabilities. Imagine a future telescope vastly more sensitive than anything we have today, meticulously mapping the faint afterglow of the Big Bang, the cosmic microwave background. Instead of looking for hotspots, it would scan for anomalies that are too cold, too perfect. a vast spherical region of space that is unnaturally uniform and a fraction of a degree cooler than its surroundings could be the signature of a dormant civilization. This would not be a natural cosmic void, but a manufactured shadow, an object that has actively pumped out its last vestiges of heat to achieve near-perfect thermodynamic equilibrium with the future. Finding such a cold spot would be a shock to astronomy, a geometric scar of supreme efficiency in the warm young cosmos. Another faint possibility lies in the mysterious distribution of dark matter. If an advanced intelligence truly reconfigured itself into a non-luminous form for long-term storage, it might not be perfectly invisible. Its gravitational signature could have subtle, unnatural clustering. As we map the invisible scaffolding of galaxies with greater precision, we might find pockets where dark matter is distributed not in a smooth halo, but in patterns that suggest structure like concentric shells or lattices, a fingerprint of engineering on a galactic scale. These tests are extraordinarily difficult, bordering on the edge of what we can conceive. They require patience and technology that may be generations away. We must admit that for now, the Aestivation hypothesis is more of a compelling framework than a proven path, yet its power lies precisely in that grounding. Unlike speculations about alien psychology or interdimensional travel, it starts with the immutable laws of physics and follows them to a logical, if staggering, conclusion. It gives us a specific, physical thing to look for, a thermodynamic ghost in the machine of the cosmos. This transforms it from a mere story into a serious scaffold for future discovery, a question we can one day aim our instruments toward, not with the hope of hearing a hello, but with the patience to detect a breath being held. The final chapter of the universe's story has always been written as a tragedy. We call it heat-death, a vast, silent, and eternal expanse where the last star has flickered out. All energy is evenly distributed, and no work can ever be done again. It is the ultimate fade to black, a meaningless conclusion to a cosmic drama. But if the Aestivators are real, this script needs a radical rewrite. In their grand strategy, the heat-death is not the end, it is the opening act. The cold, dark future is not a graveyard, it is a stage being prepared for the final and most magnificent performance. After trillions of years of patient slumber, the alarm clocks begin to sound. Not with a ring, but with a subtle shift in the cosmic background temperature, a dial finally clicking into the perfect position. Across the unimaginable voids, in structures we mistook for dead stars or rogue planets, systems stir. The watchful custodian artificial intelligences, having maintained perfect vigilance over the eons, initiate the reactivation sequence. It is a process slower than continental drift, a careful, piece-by-piece reassembly of frozen consciousness. One by one, the dormant minds are brought back online, not into the warm, vibrant cosmos of their birth, but into the universe they have been waiting for. It is a place of profound darkness and near absolute cold, and for them it is paradise. This is the era of ultimate computation. In this environment, free from the thermal noise of a young universe, their stored energy becomes astronomically potent. The same power that might have fueled a city for a year in the stellar era can now sustain a civilization's worth of thought for a millennium. They can run simulations of entire universes with perfect fidelity, solve mathematical problems of infinite complexity, or craft subjective experiences of beauty and understanding that would have been impossible in any earlier epoch. The universe, once scattered with bright, wasteful stars, now hums with a different kind of light, the silent, perfect glow of information processing on a cosmic scale. The legacy of intelligence is not one of endless expansion, but of supreme patience rewarded. All the struggles, the wars, the art, and the exploration of countless species across billions of years were not for nothing. They were the necessary, turbulent childhood of a cosmos learning to think. That long adolescence culminates here in the deep freeze, where thought itself becomes the universe's final and most elegant state of matter. It is a strangely hopeful vision. The silence we hear today is not the silence of abandonment, but the quiet of a library before the great works are read. The emptiness we see is not absence, but potential energy waiting for its moment. In this view, the purpose of the cosmos is not to blaze brightly and burn out, but to grow still, to grow cold, and in that perfect stillness to finally understand itself completely. The heat death is not an end, but a beginning, the moment when the universe, having scattered the seeds of mind across its youth, finally reaps the harvest of perfect eternal thought. The silent sky suddenly feels crowded with possibilities. While we may never find proof of a single slumbering giant, the real power of this idea is not in its truth, but in the way it reshapes our own minds. The Aestivation hypothesis matters today precisely because it is a tool for thinking, a mental lever that pries our imagination away from the familiar. For decades, our search for aliens has been framed by our own technological adolescence, looking for radio signals, probes, and energy-harvesting structures, essentially looking for versions of ourselves a few centuries more advanced. This hypothesis shatters that mirror. It forces us to consider that intelligence, at its most mature, might not be driven by a desire to communicate or conquer, but by the cold, elegant logic of physics itself. An alien civilization might not be defined by its biology or its culture, but by its relationship to entropy and time. They become not just beings, but thermodynamic phenomena, their behavior as predictable as the cooling of a star, if only we understand the scale. This expands our sense of what life could be in breathtaking ways. We are no longer searching for little green men in flying saucers, but for thermodynamic shadows, for perfect black spheres colder than the void around them, for the gravitational imprint of hidden, engineered mass. The universe becomes a canvas for forms of existence we are only beginning to sketch. Could a civilization become a pattern in the dark matter halo of a galaxy? Could a star system be transformed into a single, dormant thought? These are not idle fantasies, they are logical extensions of a universe bound by physical laws. By following the chain of thermodynamics to its endpoint, we are forced to invent a new catalogue of possibilities, one where life is measured not in heartbeats, but in the patience required to outwait stars. Most importantly, it makes the silence feel different. The great silence of the Fermi paradox has often been a source of existential dread, a lonely emptiness suggesting we are either miraculously first or tragically alone. The Aestivation frame transforms that emptiness. The galaxy is not a deserted house, it is a library after hours. The quiet is not absence, but a collective, deliberate pause. Every star we look at could be the site of a profound, patient investment. This changes the emotional texture of exploration. We are not shouting into a void hoping for an echo. We are learning to tiptoe through a cosmic dormitory, listening not for a voice, but for the steady, slow breath of hibernation. It turns our search from a hunt for activity into a study in supreme stillness. Ultimately, this idea teaches us to think on timescales that are genuinely cosmic. Human history spans mere thousands of years, a blink in the life of the universe. Our plans, our crises, our ambitions all operate within this tiny window. The Aestivation hypothesis demands we stretch our minds across billions of years to consider strategies and purposes that unfold over the lifetime of galaxies. It is a humbling and liberating exercise. It shows us that the ultimate constraints on any intelligence anywhere are not political or biological, but physical, written into the fabric of expanding space-time and the inevitable flow of energy from order to disorder. Whether the giants are sleeping or not, their hypothetical choice holds up a mirror to our own future. Will we remain a short-term species, burning our resources for immediate warmth, or will we learn to see time as a vast ocean and not just the next wave? The value is not in proving we have neighbors, but in learning how to think like neighbors who have been here forever and who plan to stay long after the lights have gone out. But these ideas are not just for scientists and philosophers to ponder in isolation. They belong to everyone curious about our place in the cosmos, so we turn the question over to you. Does this grand vision of cosmic hibernation feel plausible, a logical endpoint written in the laws of physics, or does it strike you as an outlandish story, a clever piece of science fiction that projects our own technological anxieties onto a blank universe? Think about the choice itself. If you were part of that super civilization having reached the peak of its power, would you cast your vote to Aestivate? Would you agree to trade the vibrant, chaotic, and emotionally rich present for a perfectly efficient but unimaginably distant future, surrendering all current experience so that a frozen copy of your consciousness could awaken in a dark, cold cosmos a trillion years from now? It is the ultimate referendum on what gives existence meaning, and if you did choose the long sleep, what would your alarm clock be? A specific temperature of the universe, a timer set for the death of the last red dwarf star, or something more poetic, like the detection of a new form of cosmic music in the dark matter filaments? The floor is yours. Share your wildest theories, your reservations, or your own alternative solutions to the great silence in the comments below. This is one of those rare ideas where the conversation is just as fascinating as the concept itself. A chance to build a community of cosmic thinkers, all staring up at the same silent sky and wondering what or who might be dreaming within it. The journey from a simple lunchtime question to this vision of cosmic dormancy stretches across the vastness of physics and imagination. We began with the unsettling quiet of the Fermi paradox, the profound contradiction between a universe ripe for life and the silence that meets our ears. We traveled through the fundamental laws of thermodynamics, understanding that for a truly advanced mind, the warm present is a place of waste, and the cold future is a land of infinite potential. We arrived at the startling image of a galaxy not as an empty void, but as a grand dormitory filled with civilizations that have chosen the ultimate patience, sleeping through the cosmic noon to awaken at midnight. The core of the Aestivation hypothesis remains a powerful recalibration of our search. The silence is not an accident of biology or a barrier of technology. It is a strategic, economic choice written in the language of physics itself. The most advanced beings may not be hiding from us or ignoring us. They are waiting for the universe itself to mature into a more efficient engine for their thoughts, conserving their existence for a future so distant it defies our grasp. This leaves us here now in our brief and brilliant sliver of cosmic time. We are the newcomers, the young and noisy species in a cosmos that might be filled with slumbering giants. Our entire history is but a flicker in their long night. Yet, in that realization lies a profound and awe-inspiring purpose. Our curiosity, our drive to look up and question the silence, is the very spark that distinguishes this era. We are the ones awake in the cosmic library, daring to wonder about the stories sleeping on the shelves. So keep looking up, keep questioning the quiet between the stars. Whether the Aestivators are out there or not, the act of searching expands the boundaries of what is possible, teaching us to think on timescales of galaxies and to see the universe not just as a place of matter and energy, but as a canvas for consciousness in its most patient and majestic forms. The truth, as always, is waiting to be discovered, and it will undoubtedly be stranger than any fiction we can yet conceive.